Hello, so we're back, and this time we have a customer job. This laptop comes from a computer shop, yeah? This is a nice one, yeah? It's a Acer Nitro 5, and we have i5 Agent and NVIDIA graphics, yeah? It's a nice one. So what the customer is saying, yeah? Let's see. It's kind of confusing, but let's try to figure it out. Acer Nitro was dead, no power. Replace cracked capacitor. I mean, that's weird, cracked capacitor. I mean, shorted capacitor, it is making sense. Laptop works on power, works on battery. Charging voltage when measured at the battery is 15.2, which is low. Battery charge slowly when power off. When laptop power on, battery drains even that it reads as plugged into the AC, yeah? I think it's the interseal chip. This is a power management chip. I have measured voltage here on each pin, each of the 32 pins, and some are missing or low. You know that when you measure, you just check for the chip datasheet on Google and actually check the things which matter on that chip, yeah? I will be interested to see your video and learn. Yeah, can't find this chip to try a replacement, but worth paying for you as to repair as a keen subscriber to your channel, and you have taught me a lot, so thanks. You know what? It's your achievement, yeah? So you just look at the video, but you learn, yeah? So you should give a thanks to you, okay? Good. So the customer is saying the laptop is working. Let's plug the charger. We do have the charger, the Acer charger, which is connected to the power supply, yeah? Power supply there is connected there. Plug in the charger. 10 milliamps, which is about the right current. Clearly it's not charging with 10 milliamps, but looks like the laptop it is taking power. Pressing the power button, nothing happened. Pressing the power button, nothing happened. I mean, what customer said, let me read one more time. Battery charges slowly when power off. I mean, 10 milliamps, that's clearly not a charging current. Even if you leave it 1 year, it will not charge. And what the customer said, laptop works on power, works on battery. I can't see the laptop working. I'm really sorry. Yeah? So pressing the power button, nothing happened. That 10 milliamps is kind of strange. Why 10? I mean, okay, I can get it why 10. The EC chip is powered on. But why is not reading, yeah, the keyboard power button? I mean, when you press the power button, the current should goes up. Good. Now let's open quickly the laptop and try to have a look inside. Okay, so the laptop is open. This is a nice board. Wow, I can't believe this is a new SSD. 980. I think now we have 990, right? Which is faster. Yeah, that's a nice one. So the battery is plugged in. Let's unplug the battery and see what's going on without the battery. So plug in the charger. Where is the charger? Oh, wait. Yeah, the charging port is here. Plug in the charger. It's taking the same 10 milliamps. Pressing the power button and nothing happened. Nothing. I can see sometimes it's going to 0.2. The 20 milliamps, but that's all. So it's not working. Okay, the main power rail probably it is present. But we can check that. The multimeter is on screen, it is. And we have 0.8, the main power rail. Huh? I mean, it's not right. We should have 19. Good, so what we can spot? We have the charging port. I can't see the first MOSFET, the second MOSFET, probably are on the other side of the board. I'm assuming. So let's check one more time, ground. Let's find another power supply and let's check for the main power rail. 0.6. Okay. Another capacitor 0.6. Okay, so clearly the main power L is missing. Yeah, it's missing. I mean, this laptop, it will never work. I don't understand why the customer said it's working. So can you figure it out? Probably not. The power on the charging port? Ah, that's what you want to know. The power on the charging port. 19.1, you can see on the screen. Yeah. We have a nice chipset, look there. Proper nice one. We have the BIOS chip, EC chip, GPU, CPU. Proper nice laptop, yeah? You agree with me? It's a nice one. I mean, it's easy to be fixed. Okay, so we have to follow the 19, so I have to take the board out to go behind. Okay, so we took the board out. I mean, can you spot something obvious? I just took the board out. Can you spot anything, like anything at all, obvious on this board? I'm just saying. Huh? I mean, this is blurred. You can see it's black. You can see the whole area is black. You can see it? Okay, let me get closer. I mean, that's clearly burned. You know what I mean? So, do you think the customer missed that MOSFET? No, I don't think that. No. I know how it's on a computer shop. Yeah, they are a computer shop. On a computer shop, you have to be fast. I mean, okay, so what's this job? It's 100. I can spend like 20 minutes, but no more, because I can do 2 Windows jobs. Yeah, I do 2 Windows jobs and I get 100%, £100. Yeah, but this one, if I spend 20 minutes, I can lose that time and actually I'm not making money. Yeah, that's how a computer shop works. So on a computer shop, okay, you have a gaming motherboard and you have a bunch of Windows laptops. You know what? Let's just have a look, try to figure it out if there's something here. Yeah, not taking the board out because that's long. Yeah. If I can't figure it out, okay, I will do the Windows job because I'm taking some money. And it's not about being lazy, or that's how a computer shop works. In order to be, to make money. Yeah, because it's just wasting time just for your own pride. It's not really working. Okay, good. So let's try to replace this MOSFET. I mean, clearly, it's not even point checking. Yeah, this is not short. It's interrupted. It's all burned. Yeah. So let's replace it. Let's go under the microscope and try to help this customer. Looks burned, right? Yeah. So the first one is gone. I mean, if you check with a multimeter, you can actually believe it's good. Oh, it is shorted. Oh, lol. Okay, what about with the gate? The gate is not shorted. It's like 50 ohms. What about this one? This one is good. Okay, that's kind of strange. Oh, wait. Someone play with this resistor. But the MOSFET is shorted, okay? Let's stick with the facts. Yeah, you can see it's 1 ohm. So let's take out the MOSFET. A little bit of flux. You know what? This is a common fault. I mean, we found this fault so many times. Shorted first MOSFET. You know how it is. They designed the laptop. They cannot properly test it. I mean, you test it how long? 1 week? You leave 1 week, the laptop, full CPU, full GPU. But they cannot test it. What will happen over the years? Yeah, over the years. That's the thing. So this laptop, how old it is? Like 3 years, and the MOSFET died. Yeah, so we can see the MOSFET is gone. It's like proper burned. Good. Let's rebuild the MOSFET place. Let's make it nice. Do you think it's still short? Probably not. That was the MOSFET, yeah? It's no short anymore, you can see? No short. Good. Good. Now all what I need is some rosin. Yeah, the solder is not getting here. Yeah, it is. Okay, we are fine. We are fine. I was thinking the MOSFET was welded, but no, it's fine. It's just fine. Perfect, yeah? Now let's find a MOSFET. And you know what? Someone asked on the video. Sorry, but how you can replace a MOSFET with a random one? And the thing is, those MOSFETs are quite solid, you know what? Any MOSFET, probably, like any MOSFET, it will do the job. Yeah, this is an input MOSFET. This is not a switching one. Doesn't matter the switching speed. It's just a basic MOSFET. Yeah, so any MOSFET, it will do the job. And any MOSFET, it will clearly carry more than 15-20 amps. Yeah. So basically, you can replace the first two MOSFETs by nearly any MOSFET. Try to find one. But those are dual MOSFETs, and I don't want a dual MOSFET. No, those are normal MOSFETs. 1 second. Yeah, it's a basic normal MOSFET. Let's remove the MOSFET. Those two, I use them already. Yeah. So this is an old HP board, but it will do the job. Trust me. Yeah, the board is sucking the heat badly. Come on. I can't even take the MOSFET out. And I'm like 480 degrees, you can believe that? 480. When the motherboard is spreading quickly the heat, that's the problem. You can see the solder is melting here. Okay, so the MOSFET just came out. Good, let's solder the MOSFET here. So we have like this, yeah? So it has to be like this, yeah. Has to be like this. Let's solder the MOSFET. Checking for short. 15 ohms, 18, 20, and it's going up. You know why? Because the MOSFET is too hot. Check there, 36, 37, 48, 40, 45, 47, 50. You can see? So that's what happened with the electronic components. That's why I said If you love your electronics and you want a longer life, use thermal pads over the hot components to get the heat out from there. That's why heat and electronics doesn't work together. And now it's fine, now it's not short anymore. Okay, good. Let's cool down the board. Heat and electronics, no, not so much. Okay, the board is fine. Let's plug the charger. So plug in the charger. It's taking 10 milliamps like before. 10 milliamps like before. Let's check the main power rail. So the main power rail is on this resistor, yeah? And it's 0.3. Huh? That's interesting. Okay. So here we have what we have here, 19. Here we have 0 volts. So on the gate we have nothing. Here we have 0.6. We have no voltage on the gate. You know what? Let me try something. Yeah. Let me come with the power supply to see if the main power rail is not shorted. Probably it's not, but just to be sure. Minus, plus. Sorry, this is the multimeter. What I'm doing here? Minus, plus. And it's not short. Yeah, so we are having 19 volts here and it's not short. Even here should be fine. Yeah, it's not short. Good. So what is the next step? Oh, you'll ask me. Sorry, what we are doing now? You screw it up. You replace that MOSFET, even if it was shorted, it's still not working. Yeah, it's not working because we have nothing on the gate. Let's check something together, yeah? Let's check the second MOSFET. But we check the second MOSFET, and it's not shorted, right? Let's check with the gate. So with the gate, we have nothing. Okay, so it's not short. With the gate, it's not short. Good, we have no short. So the next step is to pay attention on the BQ power management chip, yeah? So those MOSFETs are managed by the BQ chip, yeah? Which is where? BQ or intercell chip, like the customer is saying, can be an intercell chip. And it is an intercell chip. You can see it there? Yeah, there. Yeah, that's the one. Let me take the Wi-Fi card out. The problem is not much what you can do with this chip. I mean, only replace it. Let me plug the charger. Let's check if we have voltage on it. But probably the chip died because the MOSFET got shorted. So that can be a good explanation. So what power do we have on this chip? Nothing. 0.3. Why you will have 0.3? 3 volts. 3 volts. I'm not really happy with 3 volts. Yeah. Quickly, let's find the data sheet of this chip. This is an Interseal 88739. Yeah, 88739. I'm pretty sure we can find it on Google. And we found it. We found it. Yeah, screen capture. Yeah, that's our chip. That's what the chip is doing. We can see it's managing the input MOSFETs and also it's charging the battery. Wait, this is not a schematic. No, we cannot find schematic of this chip. That's sick. That's crazy. Okay, on this point, I believe we are wasting time. So what we are looking for this circuit, uh, DC in, yeah? So we are looking for DC in, so we should have the voltage from the charger and from the battery. We should have a double diode, actually. And we are looking for AC in. You see, you have a divider here. Actually, we are not looking for this because this is never get burned, yeah? So let's check the DC in pin. Now, the DC pin is, I have no idea, yeah? And I don't really care, but we can check. So we should have a look for a double diode. That's what we care for, a double diode. I mean, this looks like a double diode, and here we have 19. Check on the screen, we have 19. You can see on the screen? 19. And here we have 18. Okay. And this 18 should go to the chip. But where is it going? Because we check the chip, and we cannot... What I'm doing, I'm shorting the pins. I'm crazy. Okay. It's going here? No, it's not going here. Where is going the my 19 volts? So this is reading some current there. So this must be the voltage from the battery, and also is going to the chip. Okay. I mean, it's strange. Where is the power on this chip? How this chip is getting power? That 19 should come to the chip. That 19 volts. So from the diode should come straight to the chip. And it's not coming. I mean, I can't see 19 volts. You can see 19 anywhere? Nothing, like zero. Probably something on the other side of the board. Must be. Wait, why the board bubble there? I mean, that resistor looks dodgy. What do you think about that resistor? So here we have 3 volts. Here we have 18.6. So what do you think about this resistor? Huh? Now the second question is why this resistor got burned? And that's a very good question. Can be shorted, can be, but how we can test? Coming with the power supply, low current, yeah? So there has to be 19, remember? So low current, let's come with the power here. And it's taking 160 milliamps. So what do you think about this? 160. Lol, it's getting hot, mad hot. So it's taking 160 milliamps. 160 milliamps. First, let's replace this resistor. I mean, this is not really very important. I mean, we can replace the resistor with any value. Let me find another resistor. We found the Apple board. This is a MacBook board. This one is a MacBook board. Huh? I can't believe I have to charge this customer more because I'm using a resistor from Apple board, which is, good quality spares. Oh, we have to charge the customer more. I'm just joking, you know. So this is a 100 ohms resistor. Wait. Someone said the old resistor maybe is not burned. And that can be right. No, actually not. But yeah, it can be. Let's check the old resistor. So the old resistor is here. Let's see. Nah, the old resistor is gone. I was thinking, you know what, it's not burned and probably it was getting hot. Yeah. And now the people, it will say, oh, sorry, this is a lower power resistor. It will get burned. You know how you are using a low power thing? Yeah, transistor, resistor, whatever. And to make sure it's not getting burned, actually all what you have to do is to get rid of the heat. So what we are doing, we are using more solder. Using more solder, the resistor, it will get cooled down, right? Yeah, check here. Beautiful. That's the resistor heatsink. Yeah. Good. So what about now? Now when we are plugging the charger, probably that resistor, it will get burned. Quickly, let's check if the chip is getting hot. I mean, now it does have power because it replaced the resistor. So plug in the charger and it's taking 160 milliamps, you can see, 160. Yeah, plug in the charger. Check the chip there. And the diode, you can see the diode and the chip is getting mad hot. So yeah, this chip is gone. Where we can find this chip? Hopefully I have it. Hopefully I have it here. I remember I replaced this chip on some laptop. Because of the light, right? Yeah, check here. 88738. And we need there, what do we need? 88739. You know what? I believe it will survive. I believe it will be fine. The chip position, pin number 1. Where is the pin number 1 on that chip? It's not saying on the board. Pin number 1 is here on the corner. Okay, we can see it now. Good. Now let's replace that chip. Okay, so we remove the chip. Let's come with the new one. Perfect. What do you think? It is perfect or not? Good. Now let's cool down the board. LOL, it's so hot. Burn my finger. That's crazy. And hopefully it will work. If it will not gonna work, we have to order this chip. So what happened here? A shorted MOSFET can burn this chip? No. So a shorted MOSFET it will act as a normal MOSFET. It will just pass the voltage. And you'll say, yes, sorry, but the gate, the current can go from the source on the drain to the gate and it will burn the chip. No, yeah. There you have, actually the power rail there is around 25, 26 volts, yeah. And now you having 19 volts there cannot burn the chip. So what happened? Not sure. I suppose the MOSFET was shorted and what the laptop was doing was shutting down on heavy gaming. And probably someone try and play and touch the pins and the chip got burned. After the chip got burned, the resistor got burned also. So let's plug the power. Short. Why short? Why short? It is possible my chip to be dead. Yeah, it is possible. Checking with ground. No, it's not short. Okay. Let's raise the current because I have low current. Yes, I'll raise the current. It's very possible. This can be a symptom of low current. Yeah, the voltage goes down, the current goes up. Yeah, so I higher the current and now everything is fine. Okay, so the main power rail, it is present. That's a good question. Let's see. So the main power rail, yeah, it's not present. That's crazy. That's crazy. So the main power rail is 0. The voltage on the chip is 0. Lol. 18 and 6 volts, 0.6 volts. So my resistor just got burned. How? Wait. Let's lower the current. Let's come with the current here on this resistor. 6 volts. And it's taking 1 point something. Yeah, my chip is dead. My chip is gone. Oh, this is a burnt chip. Can we find another one? I can't believe. So either I had a burnt chip or the chip just got burnt. But probably that one, it was a burnt chip. Yeah, can be. What are the odds to have like a good chip here around? Okay, so let me order the chip and replace the chip next time because I don't have this chip. Yeah. My chip is dead. Probably it was burned from before. Yeah. It was a second-hand one. Why you will have a second-hand chip on your box? Probably, I mixed up. I put it, the chip burned. I will put it back. Like this one, yeah? This is the original one. Hopefully I'll not put it back. Okay, so see you on the next one. Bye. So we are like 3 days later, and we got a package. Now I'm really happy with the quality from the Mouser UK. The components. But the component is like £3-4 and I'm paying for the postage like over 15 because they are sending only with FedEx. So this is, kind of sucks. I mean, I pay like £24-25 for this. Let's see. But at least we know we're getting like good quality components. I bought 2, yeah, because they are cheap, like £3, and I got 2. So we have 2 chips, yeah. If I remember, this is for the gaming laptop, so let me grab the laptop and replace the chip. You know what, I'm trying to remember the job. So we replace the MOSFET, we found a burn resistor, which probably is burned even now, and we have to replace the chip, right? Yeah, let's do it. Let's replace the chip first. Yeah, that's the chip. Let me grab some flux, a little bit of rosin. Good. Yeah, we have a connector there, so we have to be careful. You see that plastic connector? We have to be careful. Let me boil the rosin a little bit. Good. Now let's replace the chip. So we got the chip out. Let me come with a new one, which is this one. Yeah, that's the one, right? Yeah, must be. Good. Let me grab some flux. Perfect. Perfect. Yeah? Yeah. Ignore that solder ball, it's fine. It's bigger than usual, but it's fine. Now the next step is replacing the resistor. I mean, I'm pretty sure the resistor got burned last time. Yeah, this one. Perfect. Okay, let me find a resistor, please. We found that another MacBook resistor. 100 ohms. Yeah, got it. Perfect. Now it's time to test, yeah? We replace the resistor, we replace the chip. Let's switch to 19. 19 volts. A little bit of current. And let's see what is happening. Plug in the charger. 10 milliamps. It's a different story, yeah? Let's check the main power rail. Let's see. So the main power rail is 19. Check that, 19.2. You can see. So everything is fine. If I check now, after the first two MOSFETs, we have on this current sensor 19.3. On our resistor, on one side we have 18.9, and on the other side we have 18.9. Everything is fine. Yeah. Let me bring the laptop and let's test it together. So I put every connector back. Let's see if it's charging. Yeah. Let's see. So plug in the charger. 1.3 amps. So the laptop is charging fine. Yeah. Let's see if it's powering on. So pressing the power button, and I can see the fans are spinning, the current is going up, and I have picture. And it's loading the Windows. Yeah, the charger just got disconnected because the current is over 5 amps. This is a gaming laptop, yeah? Yeah, I heard the laptop beep. It's working perfect, yeah? Everything is fine, and I'm happy. Let me put it all back together, nice, and test one more time. Okay, so all screws are back. This is the last one. We fix it. Usually the power problem, yeah, are kind of easy to be fixed. I mean, you can fix them, anything related with the power. Now let's do the last test. So it's charging fine. I left the charger inside. It's charging. Pressing the power button. And it does come on and working. Yeah. Okay, good. So I'll stop here, just to have an idea if you have those kind of things burned. I mean, it kind of unexpected because a MOSFET cannot be a cause for this chip to get burned. So it's strange. Okay. Thank you for watching. Like and subscribe if you like the video, like always, and see you on the next one. Bye.